Good morning, good afternoon, and good evening, everyone. So, today I'm going to be trying something a bit new, and that is I'm going to be talking about Calculus 1. Okay, so this is going to be about Calculus 1. Now, what we're going to talk about in Calculus 1 in general. So, there's going to be an entire series, Calculus 1 series. And what we're mainly going to be talking about is, well, we're going to be talking about tangents to circles. Because really, what calculus is really about is how we study change, how we mathematically define change. What is change? How do we define that mathematically? And so we start off by finding tangents to circles because this will get us into what we call derivatives, which we see a lot in calculus. And derivatives is just how we study the rate of change. So we go over tangents to circles. We also go over limits. What is a limit? Why do we care about limits? That's essentially just a tool for us to define, let's say if we have a function, where is kind of like the end if we're approaching some number. And the reason why we're studying that is, well, we want to understand the behavior of our function. And we see that a lot in engineering and business and, well, in other domains where we study behaviors of data, behaviors of functions, or in engineering, maybe behaviors of speed, right? And then we go into derivatives. Now, I know these are all pretty abstract, but derivatives is essentially where we can now kind of identify the speed of a function at a particular time. How fast is this function going at this particular time? We can determine it using derivatives. And this is useful for engineering, let's say how we want our car to go, how fast do we want it to go, or for modeling in general, how we want to model different kinds of things, how their speeds go, stuff like that. So again, still pretty abstract because we're really building from the fundamentals. And then just a bunch of derivative techniques. So other derivative techniques, because this is calculus one. So these would just be about derivatives and really understanding what a derivative is. Okay. All right. So bear with me. But yeah, that's it for this overview. Okay, so let's actually go into a new page where I'm going to go over some exercises from, well, week one. I'm actually following a course at the University of Washington, Math 124. Right. So let's go over some exercises real quick. Now, the prerequisite to this course or to calculus is, of course, pre-calculus. And so with pre-calculus, we have to know how to do algebra, how to do geometry, trigonometry. That's how we're going to succeed in this course. So here we first talk about tangents to circles. Okay, how do we go about this, right? Okay, so let's try this out. Here we have two circles. We can obviously say that, one and two. And we say we have a name for them, right? C1 and C2. And the center of C1 is at the origin. The center of C2 is this, some point in the first quadrant, because this is the XY plane. So this is the first quadrant. where the line y equals x intersects C1. So it's the intersection of C1 and y of x, y equals x. So suppose C1 has a radius of 2. C2 touches the x and y axis each in 1 point. What are the equations of the two circles? So first we need to know what's an equation of a circle. Let me grab a new pen. Can I switch this to a different kind of pen? Oh, I can't do that. Okay, let's just do this then. So we need to know, oh, that's not good. So we need to know what the equation of a circle is. Is it good? No, that's not good. This one. Okay, much better. So we need to know the equation of a circle. Now this is a pre-calculus topic. And so the equation of a circle is just the horizontal axis x minus the center. So let's just say h. We probably have seen this formula before. Y minus, let's say hk squared equals radius squared. So this is the equation of a circle, the general equation of a circle, where x would be this, y would be this, h would be some point, center, the x coordinate of the center, k would be the y coordinate of the center. Okay? So we know for C1, so equation of C1, we actually already know this. That would be x minus 0 squared, because this is the origin. This is h equals 0, k equals 0. Plus y minus 0 squared equals, now r squared, what's r? R is the radius. So that would be 2 squared. This would be 4. I'll write it like this. We can actually simplify it into something like this. So that's the equation of the circle C1. Done. Now let's find the equation of C2. Oh, okay, that's weird. Let's find the equation of C2. Now again, we need to fill up these H, K, and R. Right? So how do we do that? Well, we know what x and y is, so we can immediately put that. X minus something squared plus y minus something squared equals something squared. Okay? But how will we know what's the center of C2? Oh, shoot. I wrote C1. I meant C2. How will we know what the center is? Well, we need this point right here. How do we get that point? Well, we would need the intersection of y equals x and circle C1. Right? So we need to find the intersection of those two. So how will we get the intersection of those two? What we're going to do is we're basically going to do a system of equations here where we say y equals x and the equation of C1, right? These are the two things. This one's a line. Oops. This one's a line. This one's a circle. So what we're going to do is solve it, right? Because we have two equations and we have two unknowns. So if we want to find two unknowns, we need two equations. If we want to find one unknown, we need a single equation. If we want to find 5 unknowns, we need 5 equations. So you see the pattern? The number of unknowns that we have That's how many equations we need to find those number of unknowns. So here, let's just do simple substitution, right? We say y equals x, so maybe we can do x squared plus x squared equals 4. Y equals x. Now this should be pretty straightforward. We're just solving for x and y. I just did substitution here. This is 2x squared equals 4. You get the story. So this would be x squared equals 2. That would be x is plus minus square root 2. I think so, right? Actually, let me check. X squared. Yeah. Question mark. Is that right? You guys double check for me. X squared equals 2. Then we get x is not just square root 2, but it's also plus minus. Yeah. So what's y? Y is the same thing, right? Looks about right, yeah? Now you might be wondering why. Because x squared is 2. Now here's a rule of thumb. When we're multiplying a 1/2 to both sides, this would be x, this would be square root 2. But the thing is, we also want to take into account the negative. We know the positive works. If we square this, we get this. And that's the same as x squared. But the thing is, if we also square the negative square root of 2, we would get the same thing. That's why we consider both of them. Okay? It's as simple as that. Right. So, well, now we know our y, now we know our x. These are the centers. One of these could possibly be the centers. So the only way we can actually figure out is to look at the graph. To me, this looks like it's a positive square root of 2 because we're in the first quadrant. And the first quadrant tells us that all of the x's are positives, all of the y values are also positive in the first quadrant. So that would mean we're gonna have to pick. So we pick x being square root 2, y also being square root 2, since we're in first quadrant. And so we just fill in the blanks. We get square root 2, square root 2. And now for this radius, how do we find the radius? How do we do that? Because we need to find the radius of this. How do we do that then? Let's look at the information, right? So we have two circles. Center's origin, center of C1's origin, center of C2 is the point in the first quadrant where the line y equals x intersects C1. Since C1 has a radius of 2, C2 touches the x and y axes each in one point, or the equations of the two circles. How do we find the radius of y equals x of the circle C2? How would we do that? Let's Let's think about it. Well, okay. Well, here's the thing. Since the center is C2, the center of C2 is just square root 2 square root 2. So this one is square root 2 square root 2. That means the radius would just be square root 2. Does that make sense? Reason being, if this was square root 2, let me double check. If we actually look at it from here, going here, oh, why did I do that? Going here is square root 2. The distance of that is square root 2. That's the same thing as this. This is the radius. So this is square root 2. So really, we just looked at the figure, right? There is no mathematical way, or I think, as of now, I can't think of any, but that's how we look at it, right? Because the radius here is square root of 2, right? From here to here, that's the radius. And that is exactly square root of 2. So we also have to think about how we can use our geometry to solve this problem. Okay? Right. So now that we know that, we plug in square root 2 here. So the final answer is just going to be x minus square root 2 squared plus y minus square root 2 squared equals 2. Because square root 2 to the power of 2 is just 2. And so we have our answers for both equation of the first circle and equation of second circle. Okay, so I'm going to leave this video here. I'm going to keep it really, really simple. Yeah, I hope you guys enjoyed this problem, and I'll see you all in the next one.